I had a really cool call with a client named Aaron in Hong Kong last night, and he is setting a new standard for how homeowners in Hong Kong should be treating their homes. Apparently, in Asia, they use mini splits, ductless mini splits, as like the go-to piece of HVAC that is kind of like the cure-all. And of course, we know that that's not going to be the case, especially in places like in Hong Kong where we've got extreme humidity. Ductless mini splits do not do a great job of drying. They have a dry mode, and what that does when you turn on a dry mode in a mini split is it secretly, without telling you, cools it 2 or 3 degrees past where you tell it you want it to cool to. So instead of doing 75, like you said, it's going to go down to 72. And it's going to slow down the air to really try and squeeze as much water out of the air as possible. That then goes down the drain. In this case, Aaron's daughter has a respiratory issue, and so he was like, hey, I want to do something a little bit more hardcore. I want to do more filtration. I want to do more dehumidification, more than just a plug-in dehumidifier, which is also apparently pretty common, just like things that are kind of around the house that you have to then go around emptying all the canisters all the time. Wanted to make it a little bit more plug-and-play, automatic, not worry about it so much. So we want filtration. We want air exchange also, which in a polluted environment like a big city is something that you want to be kind of careful about. But we do have pollution that's building up, and especially inside of these smaller spaces. So we have in this location, we've got about a 700 square foot apartment, and we have these conditions. We've got a 99% heating temperature of 45 degrees. That's the coldest temperature we're designing to. The warmest temperature we're designing to is right here at 92 degrees. And the wettest temperature that we're designing to is 85 degrees. So that at that temperature, we've got 157 grains per pound of moisture in the air. And that is what we would then use for this calculation. Now, in this part of the world, they have a lot of concrete. So the deck above the apartment is concrete. The deck of the floor is concrete. The walls are also concrete. So if the windows are installed pretty well, and you can probably see whether they're installed airtight or not, we could probably imagine that it's going to be somewhat airtight. So for a smallish space, ACH 50, which is the metric that we use for blower door testing a lot, is going to it's going to punish a small space a little bit more. Also, some of the air leakage might be up and down, even though it's a concrete deck, might be to the units above and below. So really, we're looking at something like, I'd say a 3 or a 4 ACH 50. So here we want to use all this, and we want to figure out how much dehumidification we need. And at that point, then, the point of this channel is like, let's help you fix what's going on with your home. And so when I get on the phone with a client, obviously that's my job. Aaron had already done the legwork of finding out what the possibilities are next, because of course you cannot get just anything in Asia. You need to get what is available. So we have these 2 pieces of equipment. Let's talk about this one first. This one seems like it would be great. This is the Luco FDE Exchange. Whether you're reading this in English and it was written by a marketing company in English, or whether you're reading it on a Chinese website that is translating to English, but they're translating the marketing materials that are from Germany, for example, there's going to be some things lost in translation. So what this says is the Luco FDE series is a bidirectional ventilation device. That means it's balanced, right? It takes air out of your house, brings air into your house, enabling indoor-outdoor exchange of air with equal amounts of fresh and polluted air exchange. Great. It can achieve positive or negative pressure operation according to customer requirements. Also interesting. That means that we have 2 different, hopefully, it means that we've got EC motors in this thing, which in fact it does call down here in the notes. It's an EC motor device. So that means you change the speed of the fans rather than choking off airflow on one side or the other. It incorporates a static heat exchanger with an efficiency greater than 80%. Now, this one and this one both say heat exchange. This one says it's heat recovery. This one says heat exchange. What are these things? We want to know whether it's an HRV or an ERV. If you've heard me talk about ERVs and HRVs before on this channel, you know that I think HRVs are just silly most of the time. ERVs are really what you need, especially in a very cold, dry climate. You do not want an HRV. What you want is a preheater of some kind, whether that's a passive preheater or an actual electric one. But here we want to figure out what this is. Now, the first thing we need to do is convert from cubic meters per hour into CFM. And what we do is we divide 42, or we multiply 420 by 0.59. So this first one here for 420 cubic meters per hour is really doing about 250 CFM. And it can do 28 liters per day. Now, 28 liters per day is, you multiply by 2 to get pints. So it's roughly 50 to 60 pints per day. Here's the thing. If we go over now to this chart, which is really what you want, is a tabular layout of like all the things that we want to know about this, we could see that the dehumidifying capacity of this brand right here looks like it's actually grading this at 30 degrees C at 80% relative humidity. That is 30 at 80. 30 degrees C is about 87 degrees Fahrenheit. And that is going to be about 150 grains per pound of moisture. So this first rating here that says this is going to do 50 liters a day or 90 liters a day, that's if you actually just put it outside in your front lawn and you turned it on. Yeah, it'll pull 90 liters of water out of the air. And what? That's hopefully not what you're going to keep your house at. Really what you want to keep your house at is not even this 26.7 at 60% relative humidity. That's more like 80 degrees, 60% relative humidity. That's what's called the AHAM rating point, which is also dumb. What you really want to get to is what Santa Fe came out with, which is this, where they rate it at 80 degrees, 60% relative humidity, and that's fine. And then they can say that the Ultra 70 does 70 pints per day. But really, we want to look at this rating, which they don't have to do, but they're giving it to us. 73 degrees at 60% relative humidity. That's a lot more like what we would want our indoor environment to be. This thing, the 70, can only really do 55. The 98 can really only do 72. The 205 can really only do 170. So that's really what we want. You don't buy the size dehumidifier that it says on the rating label because they don't do really what they're talking about. So this one for the 90 liters a day, which I think in this environment, we're talking about like a dehumidifier is basically an insurance policy. Get the bigger one. So it can do 40.8 liters per day at more realistic conditions, which is really like 80 pints a day. Probably it's doing more like 60. The airflow range here is 380 or 580, and those are probably low speed, high speed. That's 209 CFM up to 320 CFM. And it can resist up to 120 pascals, which is about a half an inch of water column. So those are all great. That's real data. This over here doesn't really give us real data. Also, this thing says that it's got heat recovery in it, and which would lead you to believe it's an HRV, which would be bad. But right here, you can see that it's got temperature exchange efficiency and enthalpy exchange efficiency. This machine is a dehumidifier that has an ERV core built into it. This is a great piece of equipment. This one doesn't give us any information about enthalpy, so we can assume this one is just an HRV. We do not want this at that point. Even though it looks like very, this is like a lot of marketing speak, and it's great. I'm not saying this is not a good piece of equipment for certain applications, but for this client in this scenario, absolutely not. So here, this is the one that we want, and it's got two different kinds up here. We can see this one is either fresh air ceiling dehumidifier with heat recovery, two-way ventilation, or fresh air ceiling dehumidifier with heat recovery with two-way ventilation and internal circulation. And that's really what we want, because for a 700 square foot home with 8-foot ceilings, we have a volume of 5,600 cubic feet. We take any volume, we divide by 60, and it gives us 93 CFM. At 93 CFM, we're going to replace all the air inside of this apartment once per hour. That would be a nightmare in this climate. You don't want to do that. And so really what we want to do now is go over and do our ASHRAE 62.2 calculation, figure out, even though it's like an American-based calculation, ASHRAE is really an international organization, figure out that we only need really like 30 CFM, at which point, if we're going to run this thing at what it's rated for, which is 210 CFM, we want to run it 1/7 of each hour, or roughly like 8 to 9 minutes. So then we set up a timer. We have this thing run in ERV mode for 9 minutes of the hour, and then close off its damper and go into internal recirculation for the rest of the hour. Also, normally I'm recommending that people are going to use an ERV to exhaust out of bathrooms. But in this case, since we only need 30 CFM of ventilation in this small space, we don't want to have this be a continuous process of replacing all the air in the place. So if we're going to run this thing at 210 CFM, that would pull 105 CFM from each of these 2 bathrooms that are in the apartment. That's not good. So we don't want to do that. Or if we wanted to have it run in ERV mode for 9 minutes out of the hour, but then recirculate for the rest of the hour, we can't use them as bath exhaust, because then whenever you take a shower, it's just going to turn that steam right around and pump it right back into the house. And that was what we were trying to avoid in the first place. So really, if we're going to run the 2 bath fans, which are 50 CFM apiece, it's going to depressurize the entire apartment to 8 pascals. We have no combustion appliances in here. We have no fireplace in here. It's not really like the end of the world, because this is going to be a diffuse makeup of outdoor air, because we're going to get the makeup air no matter what. So we don't need to introduce some specific makeup air system for this apartment. So that was another thing that this client, being very smart, was thinking of in the process of working through this. Now, let me show you one other thing, which is how we need to duct this thing together. This is the basic layout, and we're going to need, so here's the dehumidifier that's also we could call this a ventilating dehumidifier. Santa Fe doesn't have something just like this. In fact, the reason that I'm showing you this piece of equipment is because Aaron found something that I've never seen before, and I think it's brilliant. This is a great piece of equipment. So the dehumidifier is going to go in this little cutout. It's like under a stairway. It's a conditioned space, even though it's not showing on this layout that it is. We're going to need a duct going to outside to take the stale air from the house outside for those 9 minutes in an hour, and bringing in the fresh air from outside fresh. And of course, we're in Hong Kong, so we're going to need to filter. We're going to have a serious filter here before the equipment. Then we're not going to fill the coils on the dehumidifier with dust. We're not going to fill the ERV core with dust either. We're also going to need another filter here, because when we're in recirculate mode, we're going to be bringing air from all these places, coming in here, and then recirculating it, and we want it to have some kind of a filter in line there. So 2 filters. This client, because we were talking about a daughter that has some respiratory issues, HEPA, so upsized, therefore, would be a good idea. And the way, I've been asked this a bunch of times, the way that I generally am recommending putting this thing together, you would pressurize some rooms and depressurize other rooms. And what would then happen is we would induce the air to go from the master bedroom into the bathroom, and not the other way around. Because just in case your kid goes into a bathroom and does not turn on the bath fan, which happens 100% of the time, you won't have the air in that bathroom come back out into the living space. We would constantly be depressurizing the space. It would then be able to go into a dehumidifier and through a filter, and hopefully any bathroom odors or steam would then be pulled out at that point. You could also obviously hook this up on a spike humidity sensor, but it won't pick up bathroom odors, and kids are kind of notorious. My kids don't even close the door really when they use the bathroom. Sorry, kids. They'll probably watch this when they're 25 years old and be embarrassed. Anyway, we're going to pull out of bathroom, main living space, bathroom here, and out of the bedroom as well, because it's 210 CFM. You don't want to pull all that from one spot. That would be a massive depressurization on that one room. So we're going to take from all those, we're going to dump it outside for that 9 minutes. We're then going to bring inside, and we're only going to deliver to these 3 spaces, so that then we leave these bathrooms as negative pressure zones, because you just don't want air moving out of those spaces in general. The air in there is just not what you want. So I hope that this has been interesting for you. I found this really fascinating, and Aaron, good job taking care of your family. Please do comment below if you have other thoughts from other parts of the world. And if you happen to be watching this channel from another part of the world and you have an interesting thing, let's talk. Like and subscribe. Tune in next time.